Refrigeration HVAC exam practice questions set number 12. Share knowledge, help people. And remember the words of the Lord Jesus, how he said, "It is more blessed to give than to receive." Question number 1. A component within a thermostat that is used to turn off the furnace or heating equipment before the space temperature is at the set point. A, cold anticipator. B, heat anticipator. C, humidistat. D, frigestat. Correct answer is B, heat anticipator. Number 2. When the furnace stops burning, it still radiates residual heat. A, true. B, false. Correct answer is A, true. Without a heat anticipator, the residual heat generated by the furnace is enough to cause undesirable excess of space heat, resulting in human discomfort. Number 3. A system blank occurs when the temperature of the room rises above the thermostat set point. A, overstep. B, draft. C, overshoot. D, lag. Correct answer is C, overshoot. Number 4. The heat anticipator is a variable resistor that produces a small amount of heat, causing the bimetal inside the thermostat to be blank than the room temperature. A, warmer. B, colder. Correct answer is A, warmer. Number 5. If the thermostat has no heat anticipator, its contacts will blank when the set point is reached and would result in a room temperature overshoot. A, close. B, open. Correct answer is B, open. Number 6. A furnace installed with a thermostat without a heat anticipator will still let the blower move heated air from the heat exchanger and will cause an overshoot. A, true. B, false. Correct answer is A, true. Number 7. When the space temperature falls below a desired set point, the burner will first transfer heat to the heat exchanger blank. The blower turns on to prevent cold air being delivered to the space. A, after. B, before. C, anytime. Correct answer is B, before. The burner will first transfer heat to the heat exchanger before the blower turns on to prevent cold air being delivered to the space. Number 8. System blank is the temperature drop of the heated room below the thermostat set point. A, overshoot. B, drift. C, draft. C, lag. Correct answer is D, lag. Number 9. A heat anticipator will reduce blank temperature swings by reducing large system overshoot and system lag. Correct answer is A, large. B, small. Correct answer is A, large. Number 10. A heat anticipator reduces system overshoot by opening the thermostat contacts. Blank. A later, B earlier. Correct answer is B earlier. The nichrome wire of the heat anticipator applies a small heat load to the bimetal of the thermostat, causing its contacts to open sooner or earlier. Because the resulting temperature being sensed by the thermostat is slightly higher than the room temperature. Number 11. Yeah, a small note here is effectively anticipator, uh, the nichrome wire in the heat anticipator applying a small heat load essentially or effectively fooling the thermostat, tricking the thermostat into thinking that uh, it's already reached the set point by applying that small heat load. Yeah, it's like a trick heat or a, all right. Number 11. The heat anticipator is wired in blank with the heating contacts. A. Parallel. B. Series. C. Delta. Correct answer is B. Series. How to set an adjustable heat anticipator. Step number 1. When the furnace is operating at a steady state condition, measure the current flow between the R and W terminals of the thermostat using a multimeter or ammeter. Step number 2, adjust the heat anticipator according to the current reading measured in step 1. Note, if the heat anticipator is set at a higher amperage setting, then greater system overshoot would result. Number 12. If the resistance of heat anticipator increases, the space temperature blank. A decreases, B increases, C remains constant. Correct answer is B, increases. How heat anticipator works. A typical heat anticipator has current scale from 0.10A to 1.2A, which corresponds to the amount of current in amps that will flow through the small heater of the heat anticipator. The small heater inside the heat anticipator is a coil of nichrome wire. An example of a heat anticipator model is Honeywell T87. So this is the simple analysis here. A longer wire means more electrical resistance, less current flow, less heat generated by the heat anticipator, less pre-warming of the thermostat, heat is not turned off early, burner runs longer heat on cycle, warmer space temperature, and space temperature increases as a result. Okay, so the 0.10A setting, this is the shortest heat on position, the shortest heat on cycle. Thermostat will turn off the actual heating system off sooner or earlier. The 1.2A setting, this is the longest on position, the longest heat on cycle, and the thermostat will turn off the actual heating system off later. It's yeah, it's a longer heating cycle operation. Okay, this is it for this set. Hope you learned something. I'll see you on the next video. Cheers, have a good one.